Hello everyone, in this video we're going to be discussing tessellations, which begins on page 616. This is really where geometry and mathematics meets art and a lot of actually, construction and architectural ideas. Alright, so a tessellation is a collection of figures that covers a plane with no gaps or overlaps. Alright, so we can't have either of those things. You can use transformations to make tessellations. A regular tessellation is a tessellation of congruent regular polygons. Alright, so they do have to be congruent, regular, and polygons. In the figures above, the tessellation of the equilateral triangles is a regular tessellation. Notice that all those triangles, even though they're different colors or different shades of blue, they are congruent. They do use a, reflection here and perhaps even, a horizontal or vertical shift here in order to create this beautiful pattern. Now, this particular figure, it is not a regular tessellation, even though it's just a regular tessellation. It's not regular because each of these shapes, the two different shapes, or four different shapes, in fact, that we have here, they are not regular, alright? They don't have congruent sides, they don't have congruent angles. They are polygons because they are closed and have three or more straight sides. One additional thing is it's convex. So let's look at creating our own tessellation. So you can create your own, tessellation or little art project by starting out with an index card. So if I take an index card and, I cut out whatever sort of wonky shape here out of one end and off of another end, I can then reattach it on the opposite side of my index card here. So my final product here is the top of my index card with my new triangle on top, and then I now have this piece missing right here on the right side, and then I have that triangle missing on the bottom, and then on my left side here I do have this piece that was added on. Alright, so if I were to shift this left and right or up and down, I would create a neat little picture here. And you can of course put a design on, this, and I can create some sort of monster with multiple eyes and a mouth and maybe a snap. I have no idea. Alright, so this is just an art project that maybe it's an idea for those of you that are in art to create a tessellation. Alright, so example 1. Does the shape tessellate? So it's going to help you to draw these figures out and, shift them up, down, left, right. Can you create a picture without gaps or overlaps? So here in part A, you can see that they lined up, a whole bunch of octagons for us. Alright, these 8-sided figures. They are regular octagons, but as you can see, either a gap is created or an overlap in order to get rid of the gap. So this does not tessellate. Alright, regular octagons do not tessellate. Part B here, looking at a trapezoid, notice that it's not, perfect or anything like that. Trapezoids do end up tessellating, so I, shift it and there is a little bit of a gap. So if I were to draw it like that, so they shifted just a little bit more and they actually create this tessellation by reflecting it. That's perfectly fine. So they end up reflecting it and then doing a horizontal shift. And then they reflect it again and then do a vertical shift to repeat all those rows there. Alright, so it does tessellate, that's good, but it is not regular. And then in part C here, a regular hexagon. This should be a very familiar shape actually. for a tessellation, as it looks like a beehive. Alright, so a regular hexagon does tessellate using translations, and it is regular because it is made out of regular hexagons. Alright, so let's look over here at this kind of little hint off here to the side. So the sum of the angles surrounding every vertex, so let me erase some of my marks on here so that I can highlight them a little bit more. Alright, so here is a vertex, here's a vertex, here's a vertex. If I go back a couple of slides, here is a vertex. Alright, so the sum of every vertex is 360 degrees. That's how many degrees are in a circle, so that makes sense. This means that no regular polygon with more than 6 sides can be used in a regular tessellation. So if, we break up a regular, a couple of our regular tessellations, so this one, and I look at the triangle, and I divide, that 360 degrees by the number of angles that meet there, so here I have my 360 degrees by the 3 angles that meet there. That means they're all 120 degrees. If I go back to my triangle here, I have 360 degrees divided by 1, 2, 3, 4, 5, 6 triangles, so that gives me 30 degrees. If you were to go any higher than that, even though 8 is perfectly divisible, as you can see, with an octagon, right here in part A, it ends up creating a gap. Alright, so with an octagon, I don't have 8 sides equally meeting. I actually am only going to have, 2 sides of an octagon meeting with a square. Alright, so let's go ahead and look at example 2. Change a triangle to make a tessellation. So here I have a triangle, and we did kind of the method I was talking about. You cut one piece off of a side, and then you attach it to another side here. So then if you flip it and translate it, so they flip and translate, they translate and reflect here, alright, you are able to make your own tessellation. Example 3, draw a tessellation using 2 shapes. Alright, so think about floor tiles. There's lots of patterns here. This is a very common floor tile that you would see with kind of black and white tiles. So combine an octagon and a square by connecting the side lengths, or connecting sides of the same length. So then you translate the pairs in order to make a tessellation. This is not what would be called a regular tessellation, but it is what would be called a semi-regular tessellation, because it is made up of a combination of regular quadrilaterals here, squares, and regular octagons. Alright, so there are also, really pretty patterns that are made up of several types of regular polygons. So that, yet again, would be called a semi-regular tessellation. Here are your practice problems for this extension. If you guys have any questions, always feel free to email me or take advantage of those office hours. I look forward to hearing from you, and more than that, I look forward to seeing your beautiful art.